So, welcome to this question on 2012, question B4, section B, right, solids in contact. So we have the arrangement of ceiling lights, 3D graphic shown here for help. Draw the given elevation and plan, showing how to obtain the center of the sphere C. So I can start drawing the elevation of cylinder A, its diameter 40, okay, the extreme generator is in line with the base of the cone. The base of the cone is 70 as given in plan. The radius of the cut surface here, the circle, is radius 15 and it is a height of 60 millimeters from the XY line, and then I'll have to draw in the sphere C. So I'll start with that now. So XY line, I'm going to mark up 60 mil from the XY line. So I'm going to mark up 60 mil horizontal line across. Now I'm going to start my cone here, my cylinder rather, roughly on the center of the left hand side of the screen. Okay, or the sheet, diameter 40. Total height of the cone is 60 as well. And then there's a portion of it that's cut. So the angle it's cut at is 30 degrees. Now, the cone, the diameter is 70 at the bottom and the radius of the cut surface is 15. So I'm going to mark 70 along the bottom here from the extreme generator of the cylinder, and I'm going to mark the center point here at 35. And then I'm going to mark 15 either side of the center for the vertices of the cut circle. I'm going to bring those two vertices, the radius 15s up, okay, and to the 60 millimeter height line, and I'm going to bring the center line up. Now, I'm going to join the base through the vertices of the cut circle because, right, we're going to need the apex of the cone later. So I brought them through, and then I'll do the same here. And heavy that in that portion. Now, to find the center of the sphere, okay, it's tangential to the XY line, okay, and it's tangential to the extreme generator, okay, and the radius is 25. So what I'm going to have to do is bisect the angle between the XY line and the extreme generator. So I'm going to bisect that angle. So the center point of the sphere lies along this line here. I'm going to go up the radius of the sphere, which is 25. So I'm going to go up 25 and I'm going to draw a light line across. There's the center point. Now, to find the point of contact between the cone and the sphere, the circle is the extreme generator of the cone is a tangent to the circle. So the point of contact between the tangent and the circle lies in a line at 90 degrees to the tangent from the center point. So I'm going to line up my set square with the extreme generator of the cone, slide it down to the center point here, and draw in the normal, and that's the point of contact in elevation, and that's the normal there. Now, then we can draw in the sphere, which is a radius of 25. So I'll draw that in now. So there's the point of contact drawn in elevation and the sphere. Okay, so I can heavy in the cut surface. Now I can start on the plan. So drop my lines from elevation down to plan. I can start the plan then below the XY line. So radius 20 for the cylinder. Radius 25 for the sphere. There's the point of contact in plan. The cut surface. In detail. So the next part of the question, we have to develop the cylindrical surface A. Okay, so I'm going to divide this up into 60 and 30 in plan. bring the numbers up onto the cut surface and elevation. We're going to unwrap the cylinder this way, so I'm going to step the distances between the divisions from plan along this line, and I'm going to number them, and I'm going to bring the relevant numbers or corresponding numbers to their relevant positions here. Now, I have to start at the shortest number, okay, which is 6. So this is going to be 6, 5, 4, 3, 2, 1, 0, 11, 10, 9, 8, 7, 6. Okay, because the development has to join at the shortest seam. Now I'm going to bring 0 to 0, 1 to 1, 11 to 11, 10 to generator 10, and 2 to generator 2. So look, I bring 2 across until it hits 2. And 6 and 6. Now I'm going to heavy, sin. And then I'm going to freehand sketch these points in. Right, so that's the conical surface done, or the cylindrical surface developed. The next one is draw the develop of the conical surface B that has been cut, and it is hollow underneath, so we won't need a base. So we're going to have to divide this into 60-30, okay, so we are in plan. Now we have to extend up that line. This is a true length here. So we're going to take the true length of the cone. So put our compass on the apex, find the true length. And I'm going to put my compass out here. Okay, I can start it wherever I want. All right, and I'm going to swing a big arc there. I'm going to mark the center. I'm going to draw in one line for the extreme generator of the cone. So that's where it starts. Now, I'm going to take the distance between the division lines here. So I take the divisions with my compass, okay, here, and I'm going to step it, okay, along this arc, but I'll have to label these. So these are going to go on 12 times. So I marked all them along with my compass. I kept going around, just kept stepping them along the arcs. Okay, for 12 times. So that's 6 K J I. So we join these back to the apex. Now we're going to take the true length of the cut section here, so compass to the cut surface here, and we're going to put our compass on then the apex then. So we heavy that portion in. And that's the question complete then. Cheers, thank you, bye bye.